the screen is visible. Thank you, IPA, for this opportunity and to have a topic in the recent trends in the extrusion process. And I'm glad to be present the paper on benefits of gravimetric feeder in the plastic extrusion process. So before getting in detail into the context, I will just give an introduction about the feeders. Okay. It is actually a device that weighs and controls the flow of material to a downstream process, example an extruder. And I thank especially Mr. Chandra sir for having a presentation on the extruder, so which will be very helpful to link the concept. Like this is a device used to input the material in the extruder, which has been explained in before presentation. So why this is used is as it can automatically control the throughput of individual ingredients.
Yagnaraman, your voice is too low. You can put the speaker near to your mouth.
Okay, sir.
Okay.
Fine. Yes. Sorry for this. And it can feed the material automatically and controlling the individual ingredients in a continuous process. It has various applications. It is being used in compounding, engineering plastics, master batches, polymerization, and food and even pharmaceutical applications. So this to give a view on the structure of the feeder, how it will be. So with this movement, we can able to feed the different materials smoothly. And to give you a view how it will be installed in the factory, this is a practical example where our gravimetric extruder for individual ingredients, identical feeders are being used. So why this feeding accuracy is given such importance? We like to explain with an example. Let's take the automotive industry. Like recent times, there has been several changes in components of automotive parts into plastic to achieve the weight reduction. In such case, the precision and performance of the parts should be ensured. It doesn't affect the performance of the vehicle. So some of that are durability, heat resistance, and even weather resistance. So when coming to such manufacturing process, in before case, single function compounding used volumetric feeders, where the number of ingredients used are very less. Whereas in case of multifunction compounding, there are n number of materials used in the compounding process for which high precision gravimetric feeders are necessary to ensure the ratio of the materials in the recipes. What materials are being used? It ranges from pellets, crushed materials, fibers, and powders. And certain materials have different characteristics, even multiple characteristics. So which helps to analyze the nature of flow from easy to difficult. How we characterize is we consider 4 points to analyze the characteristics of materials. One is the bulk density. We check the bulk density of the material in loose condition and tight condition, and we check the gap between them. The more the gap, the stronger the tendency to have fluctuation during feeding or possibility to have bridging. Second, angle of repose. It is the angle formed when the material is lived downwards, and we can see here the angle. If the angle is small, then the flowability will be good. Whereas if the angle is large, then there will be possibility for difficulty in feeding. And third will be the size of particles. The materials which have been used, if the size and shape of the materials are uniform, then it is easy to feed. Whereas the particle size are big and non-uniform, in case of recycled materials, then it will have certain issues which has to be considered. And finally, melting point. This shows the temperature change of the material. If the melting point is of low temperature, then it possibility to have adherence or sticking near the rotation part, for example, screw. So in this case, the feeder should be selected which could attain the required feed rate at a very low screw speed to prevent this issue. So on analyzing these aspects, we have a lineup of feeders ranging from screw feeders in twin screw and single screw configuration, which can handle wide variety of materials. And next will be the belt feeders, which is a very space saving option. In same ways, we can achieve high feed rate outputs in several tons per hour. And third will be the vibratory type. It is mostly used for the fiber material with which the loosening of fibers due to screw rotation can be prevented. And finally, will be the pump type, which is mainly used for the liquid materials. like flame retardants or any additives or pigments like that. So now coming into the content for today's topic, how we express the benefit of gravimetric feeders, we take the 4 aspects. First, we will be discussing on the structural difference of volumetric and gravimetric feeders. These are the prominent type of feeders available. So let us get into detail. First, volumetric feeder. It is very simple in design. It has a feeding hopper, screw unit connected with a motor shaft and a motor controller to control the speed. So its principle, it works, discharges the material based on the fixed screw rotation speed which we set, for which calibration has to be done in advance to find which screw rate can be achieved at the particular screw speed. But there is no control in feeding during the operation process. Coming to the gravimetric feeder, it also has a similar feeding unit. It consists additionally an weight sensor, a load cell, and a feeder controller, motor controller, and an operation terminal which can input the values. So in this case, the operation principle varies. First, the load cell checks the entire weight of the feeder with material, and then when we input the required feed rate and the operation starting, it checks the discharge loss in weight of material and gives feedback to the motor controller, which calculates the approximate screw speed required to achieve the target feed rate. So in this feedback mechanism is checked continuously. So how it will work is, whenever the discharged weight of material is higher than the target amount, the screw speed is lowered, or else when the discharge amount is lower than the target amount, the screw speed is increased to maintain the target feed rate constantly. Next, how it helps in the increment of quality control. Let's take a practical example in a compounding line where the feeders are being volumetric feeders are used. The initial charge amount can be measured and input, and we can set the screw speed based on our calibration, but there is no measurement at the input of the extruder because there is no weight control in the volumetric feeder. So the measurable data only on 2 aspects. One is the starting point and at the end of the process. Whereas in gravimetric feeder, the initial material can be measured and fed to the feeder, and same, each discharge weight of the feeder can also be measured and the final. So we can have a verification of the recipes ratios at the starting, at the end point. Next, how it helps on the quality of the material. When coming to the high value added plastic compounds, high feeding accuracy of material is very much necessary to ensure the performance of the materials. In this case, our feedback control mechanism helps very much to achieve this. Let's get into some testing, how this can be ensured. We have taken a screw type feeder of twin screw configuration. We have taken the same feeder on 2 configuration. One is gravimetric and volumetric mode, and the feed rate to be tested is example 10 kg per hour. For volumetric, we have done some pre-calibration test to find which screw speed is required to meet the 10 kg per hour configuration. So the materials taken here are around 5 materials, from pellets, powders of different types like talc, calcium carbonate, and titanium dioxide. The points to be considered here are feeding accuracy and the feed amount. So what is feeding accuracy? It is the discharge variability of the flow at a given time for a calculator of 10 continuous samples. Here the unit time will be 60 seconds, that is a minute, and for 10 samples. And also based on the samples, average and standard deviation are calculated to find the feeding accuracy. And next, feed amount in unit time. In our test, we have taken the set value as 10 kg per hour. So here the unit value will be 1 hour. So the target amount to be achieved at the end of 1 hour should be 10 kg or 10,000 grams. So we have taken here the result of titanium dioxide, which is one of the difficult material to be handled in. So we can see here, the graph shows for the volumetric and gravimetric feeder. As we know, the volumetric feeder operates on the fixed screw speed. The motor percentage remains stable, but there is huge variation in the output of the feeder, which in result, we can see there is a shortage of 600 grams of the total material. Whereas in gravimetric mode, the motor varies continuously to maintain the constant flow of materials. So here there is a shortage of approximately 10 grams. And as per our formula, the feeding accuracy achieved is almost 3.94%, and for the gravimetric mode, the accuracy is 0.47%. The least the value, the better the accuracy will be. But there might be a case like we done several calibration in advance to find the which motor speed is required to achieve the feed rate, then why so much fluctuation? There is a cause for this issue. We will explain in detail. Pressure created by the material in the hopper. As the powder material is fed into the hopper in a full condition, there is certain pressure created in the downward direction, which leads to high fulfillment of material into the screw part. As the feeder operates and material is being discharged, this pressure decreases gradually, and this leads to reduce in pressure, which automatically has low fulfillment into the screw part, and this causes the fluctuation. Let's see how it has an impact with another powder material. This time with the talc, we are analyzing the statistical data of three aspects. One is the weight of material in the hopper, and next is the motor speed, and next is the fluid rate output. So here we can see both the feeders have started with 20 kg of material in the hopper, and it has been run continuously till total material is being discharged. So it has taken 120 minutes, approximately 2 hours. So here the feed rate, let's take it 10 kg per hour. Volumetric feeder runs on constant speed. So initially the flow is good, but as the weight of material decreases, we can see the flow also decreases gradually. Whereas in gravimetric feed, as the weight of the material decreases, based on the feedback mechanism, the motor speed is being increased drastically to maintain the stability of output. So in this case, output can be assured without affecting the performance. So coming to the summary of results of all the materials, for pellets, there is no big deviation, but for specially powder materials, we can see there is a deviation of minimum 2 to 6 times in the accuracy between volumetric and gravimetric type. On the second aspect of feed amount in unit time, for target value of 10,000 grams, in most of the cases, we can see with the volumetric feeder having either shortage or over input of materials in the specific amount, whereas in gravimetric mode, there is very minimum thing which is negligible. So in both these cases, we can be sure that gravimetric feeder helps to ensure the recipes are in the perfect ratios, which won't have any effect on the final product. And next, how this helps in the productivity. Let's check both the operating condition with the line starting with volumetric feeder as well as gravimetric feeder. Initially, both the feeders has to check the flow max. That is, the maximum flow rate could be achieved with the 100% capacity of the set screw. So once completed this flow max, in the volumetric process, calibration sampling has to be done to find out what all flow rates can be achieved in the respective screw speed. And then a calibration curve has to be made to point out the required output ranges as per their production schedule and check the feed rate and start operation. Whereas in case of gravimetric feeders, post checking the flow max, we can directly input the required target feed rate and check the feed rate once and start the process. So in this case, we can save almost 50% of the startup time. This will be very much helpful when the factory have a multiple grade change options. So in this case, the startup time can be saved very much. Next, another process we can save is pre-mixing process. In some, when multiple ingredients are to be used, some might use a high-speed mixer to mix the granules and powders and then feed it into the volumetric feeder to the extruder. In gravimetric mode, this can be saved multiple ways. Like first, additional space for the premixer and also the mixing time, where individual materials can be fed through identical gravimetric feeders directly to the extruder, and this can also eliminate the segregation problem, which have a bigger impact in the final products. What is segregation is, since the granules and powders are mixed together, in some cases the heavy granules can settle down and the powders may stay up top, so which will have an impact on the final product on quality issues. This can be avoided with gravimetric feeders, as it will be discharged separate feeders.
Yagnaraman, again you adjust your mic.
Okay, sir. And next will be a very important aspect like error detection. This is very much necessary in the shop floor. Like the earlier we detect the errors, the lower the losses will be. So in case of volumetric feeder, we can see there is no control in the discharge output. Only if there is a motor break, there will be an error raised. Until that, there will be no error. So if there is a variation in the discharge output, it can be detected only when the quality team inspects the end material of the extruder and finds out. But before that, more materials will be produced already. Whereas in case of gravimetric type, we have several options